I'm going to record the lesson and then I can just make a link so that way if you miss something, you can, I don't have to like reteach it or you don't have to get a tutor. Okay, so looking at the first sentence, the expressions 4K plus 8K and 12K. Well, what happens if I combine those?
They're like terms.
They're like terms?
Yeah.
They're also called equivalent expressions. So equivalent expressions. Why are they equivalent? What's equivalent mean? They're equal to each other. Good. Now, I like what Jack said about like terms. We're also going to be looking at like terms because they have the same variable, right? So whenever they have the same variable, we can combine them. Now, we're only going to do a few properties. Aaron, you had mentioned distributive property or something. Okay, we'll get to that eventually. Okay, for today, we're only going to do 5 of them. Okay, first one is substitution property, which actually we've already done. This is kind of like saying, if I say x equals 2, then what would 3x minus 1 be equal to? So if I say x equals 2, what would 3x minus 1? What would we do?
Wait, x equals 2, so
We would leave it the same.
Okay, what are we doing? We're replacing
5.
No, we're replacing x with 2.
X
So
with
it'd
2,
be
and then
5
you
minus
use
1 is 5 minus
So
1
it'd
is 4. So
3
the
times
answer is
2.
4.
No,
it's
6 minus 1.
Correct.
6 minus 1.
It's 5.
Yes, sir, Aaron.
Okay,
Yes, Aaron.
so you got 5. Okay, next one. We're going to do additive inverse. These are basically opposites of each other, okay? And what happens when we add opposites to each other? So if I take A and negative A, they cancel, and we always get 0. Okay, so we're...
Why is it in parentheses?
Oh, just to make sure it's a negative number, so we're not thinking like... It doesn't have to be in parentheses.
Could you also do just A minus A?
You could also do A minus A. The reason we say additive inverse is to show it's A plus a negative A. It's the same thing. So if I said, correct. So if I picked a number, let's say negative 8, what would I add to that to make it equal to 0? What's the opposite of that?
8.
Just positive 8. Yeah, of course. What if I had a positive 1/3? What would I add to that to get 0? Negative 1/3. Okay, so they're just opposites of each other. Those are additive inverse. Okay. And we could just, this is just a typo here. Multiplicative inverse. Have we heard the word reciprocal before?
Yes.
Okay, reciprocal is when you
Switch the fraction.
switch the fraction. So when we multiply reciprocals, we always get equal to 1. So they are flipping one fraction. So if I said
That's like when you're doing division.
2/3, what would I multiply by, Aaron? 3/2.
Whoa.
Okay.
Oh, the reciprocal.
The reciprocal, we just flip it.
Yeah.
Okay.
I remember that for easy stuff.
Wait, I don't.
Okay.
Oh,
Okay, now what if I said -4?
Yeah.
Okay, if it's negative, my no, that's for
Wait,
additive.
this makes sense actually because if it's a fraction and then you switch the numbers, it's always
Okay,
going to be 1.
So what if it's a whole number? What if it's a 4?
You do a decimal.
Well, you could make it into a decimal, but
Oh,
how
percent.
could you do the reciprocal?
Oh, positive 4. I just said that. She said no.
Not positive.
She said.
Negative
Said
4.
she said.
Yeah.
No, I'm still not hearing. Okay, can I put this first number, can I put -4 over 1?
Yes, again. 1
Now what happens when I flip that?
1 over 4.
Becomes
-1/4. Okay?
That's the same thing, right?
Well, they're opposite.
No.
So they're flipping
Yeah.
the one fraction.
Ooh.
Wouldn't it be -1? Oh wait, no, because it's 2.
Okay, additive inverse, one is positive, one is negative. With
Yeah.
multiplicative inverse, they're either both positive or both negative. Because what do we need to end up with? We need to end up with a positive one. If one was negative and one was positive,
It would just be negative.
then it would be a negative one, which we don't want. We want that to be a positive one answer.
Okay, it makes
Okay.
that makes sense.
What is the additive inverse of negative 8?
Yeah.
Say it.
It's 8. It's
8, positive 8. Okay, additive inverse, we just changed the sign. Okay? Multiplicative inverse, Jackson.
4/3.
4 over 3, we flip it. Good. So additive inverse, we change the sign.
So-
Multiplicative inverse, we just flip it.
So negative 0. Additive inverse will be negative.
No.
Yeah.
Oh,
Okay.
Yeah, this makes
So
more sense.
additive inverse negative 0.5.
Positive 0.5.
But okay, additive inverse, you just changed the sign.
So
Multi-
positive, you then-
Okay, so additive, we changed the sign.
So it will be 50.
And here, multiplicative, we flip it. Okay? So multiplicative inverse, we flip the number. Additive inverse, we just change the sign. So if it's positive, we make it negative. If it's negative, we make it positive. Did the number itself here change at all? No. Okay? All right, moving to the next page. One more of these. What is the multiplicative inverse of negative 10, Rachel?
10.
Okay, that would be additive
No
inverse.
wonder you gotta like flip it, so it'd be like 10 minus 10 over 1.
Okay,
Times
Aaron?
negative
What?
10.
Doesn't make sense.
I have no
No,
idea.
it's times.
If you
times
want,
negative-
right?
1 over what? Here.
1 over 10.
Okay,
One
here's
over
the thing.
negative 10.
We have, when we have a whole number, we want to be able to flip it. The only way we can flip it is you can put any whole number over 1. Now can we flip the fraction?
Yeah.
So this will be negative 1/10.
Okay, that makes sense.
Okay.
It makes sense. Because if it's a 1, then it could always
Yeah.
be like a 0 or 1.
Is either like gonna break my brain or it's gonna be.
It's not. It's going to be fine. It's going to be fine.
And
It's fine.
Okay. All right. Commutative property and associative property. These will be the last two things.
Oh, yeah.
And then we'll do some more examples. So commutative. So think about if I say you commute from home to school and back from school to home. Commute means going back and forth.
Oh yeah, because if you like 1 plus 2 plus 3 is 5, then 3 plus 2 is 5, and like same
Excellent.
thing.
So you can change the order.
Actually, wait, is it?
Yeah.
So wait, Jack, you just gave us an example. You said 2 plus 3 is the same thing as 3 plus 2. So I can change the order around. Could I do the same thing with multiplication?
Yeah.
Yes.
Yeah.
With division and yeah.
Okay, division and subtraction, not the same. So we can only do this for addition and multiplication, because if I put 5 times 6, that's the same as 6 times 5, right? That's 30 and that's also 30. Division does not work the same and subtraction does not work the same. So it's only addition. Well, we don't have to worry about that here. Only doing addition and multiplication. Okay, associative. Oh, yes.
Oh, can I go back with you?
Okay, associative is the way you group, and the order does not change. So here, do you have parentheses around A and B on your paper?
Wouldn't the answer be different though? Because you're multiplying.
No, these are just adding
No, but
here.
under the A plus B plus C.
Well, does it matter if I add A and
Under it.
there's parentheses here though, right? On your paper.
So A times B.
Right, but what I'm saying here is you can group the numbers differently. So for example, here, I can move the parentheses around.
Oh.
And I can do the same thing with multiplication. So look at the order. It goes A plus B plus C, A plus B plus C. All I moved were the parentheses. A times B times C, A times B times C, the parentheses moved. Again, this only works for addition and multiplication. So what would be an example? Well, give me 3. Yeah, go ahead, Rachel. You could do
Addition?
you could do addition or multiplication.
2 plus 3 plus 4.
Okay, and where do you want to put the parentheses around?
2 plus 3.
Okay,
So 5.
so that's going to be 5 plus 4, which
I
would
don't know
be
that.
9.
Ooh.
Could I change this to grouping the 3 and the 4 together? Yeah, 7 and 2 also adds up to
Addition
9.
will always be the same.
Addition and multiplication will always be the same. Now,
Isn't addition like multiplication but like weaker? What? Kind of. Like multiplication like addition but like strong.
Yeah.
yeah,
Wait.
well, multiplication is multiples of adding. That's why it's called
Can you scroll up?
multiplication. Yeah.
Real quick.
Okay, now on the worksheet today, and what we're going to do for just the last part here, we're going to try to add these or multiply without using a calculator. Okay?
What?
The goal of commutative property, I want to move things around. Okay, so instead of doing 2.5 plus 3/4, I'm going to move 2.5 and I'm going to add the 1.5. I'm going to group these two together.
3 point. No,
Well,
4.
that's a negative.
And then I want to add,
4 plus.
That's a negative.
that's okay, that's okay. I'm still grouping.
4 plus 2/4, which is.
Do you understand what I've done? So that our goal is to not pick, I know, Jackson, I see you with your calculator, but our goal is not,
I'm closing it.
okay, he's closing it so he's not tempted. So
What did you
what
do?
would 2.5 adding to 1.5 give us?
4.
Four.
So silly.
You failed.
Okay,
Smiling while you're saying the story.
And now it's 2 over
let's stay
4,
focused
which
here.
is 1 over 2.
Okay, what happens when I do 3/4 minus 1/4? Yeah,
You get 2/4.
2/4.
Reduce it, which would be 1/2.
good.
Equals 6.
So 4 plus a half
It's 4.5.
is 4.5.
Beautiful.
Absolutely gorgeous.
Okay, so we're going to do the same thing for these last 4 examples. So I want to switch some things around. What do I want to switch? I want to put the decimals together.
Is that -1 or
So-
minus?
It would
Minus
be
1.
1.5 plus 0.5, you'll get 2. So instead, you get 2 plus 3 minus 1. So 2 plus 3 is 5, minus 1 is 4.
What the
You got that right.
Good.
What just happened?
You didn't, you know.
Do I have to write on the paper if I did it in my head?
Well, that's kind of the idea here. I mean, listen,
The whole point is to do it in your head.
it is part of using mental math. That's the whole goal, is trying to figure out how do we rearrange things. Okay,
But my second grade teacher said actual math was bad.
Yeah, same.
it's not bad. It's not bad. I'm trying
Never
to.
regroup with mental math. That's what she
Okay.
said on the table.
What do I want to switch around here? I want to switch around the 3/4 and the 4/3. And then I want to do the 1/5 times the 10. So I'm going to multiply. Why would I rearrange the 3/4 with the 4/3? What happens when I multiply those?
It's gonna be like really easy. It's gonna be like the one of the properties that we learn like already figure out the name.
3/4.
Multiplicative, inverse,
I said that.
reciprocals.
3/4 times 1.
What happens when I multiply reciprocals?
Then we do the
So you do
reciprocal.
3 times 4 times 4 times 3.
Okay, but what happens when I multiply 3/4 times 4/3?
You have to split it because it's
What-
reciprocals.
So, but what do I get here?
You get 4 times 4 is 8, and 3 times 3 is
It's
6.
No, no,
one.
don't cross
It's
multiply.
1.
Multiply straight across. 3 times 4 is 12.
12 and 12, so you get 1.
Go ahead.
So then it would be 1
Times-
times
Okay, what's 1/5 of 10? What's
5.
what's one? But
Oh,
what?
2.
2, because we'll have 10 over 5, which is
So then it would
2.
be
1 times 2?
2.
2.
Yeah.
Yeah.
Okay, here I'm going to switch.
Oh,
10.
class is until 3:15, right?
Yeah.
Yes.
We have plenty.
Oh, it's last class of the day.
But you know what?
Okay, what's 10 times a half? What's 1/2 of 10?
5.
5.
15. You're back, Charlie.
I'm back.
Very aesthetic.
What are we doing now?
Only the nose.
Okay, Brady is.
8 of the notes.
What is happening?
Oh,
I got 5.
15 times 5.
Oh, I
Yeah,
What's
don't forget to
15?
multiply it. Okay,
Alright.
last one. We have 2/3 times 9. Let's switch this around. Okay, 2. So remember when we're multiplying fractions, 2 times 9 would give us what?
18.
18. What's 18 over 3?
18 over 3 is 7.
No,
18 over 3 is, that's 6. But,
No,
Yeah, no, you got it.
6.
6.
Yeah.
Are you supposed to do the
I'm the
parentheses
best.
first?
But we're moving. Okay, the whole goal, I think you were in the restroom, we moved the parentheses around.
No, it's like 30.